Jupiter is a major planet in our solar system. Not only is it the largest in terms of mass and size, but its influence can be seen throughout our entire solar system. If we talk about Earth, this planet acts like a shield for our planet. Any object coming from outside has to pass through Jupiter's intense gravitational pull. Because of this, the object coming towards Earth changes its path, and Earth is saved from another terrible disaster. We may never be able to count how many times this giant planet of the solar system, Jupiter, has saved Earth and human civilization, but humans have always been amazed by this planet when looking up at the sky. From Galileo's first observation of Jupiter to today, we have certainly learned a lot about this planet. From a faint dot, we have peered deep inside Jupiter and studied it up close during the Voyager mission. But just this much is not enough to know and understand this giant planet. Dedicated missions have already been planned to study Pluto and Saturn. So how can Jupiter escape the eyes of scientists? How much do we really know about Jupiter, the one that protects us and this Earth from catastrophic disasters? Jupiter is maintaining the balance. Our civilization not knowing about it could be dangerous for us. What exactly is Jupiter's role in our solar system? Is it much more important than we think? What's happening inside it? And is there life on its moons? There are many such questions that still force us to look at Jupiter with a sense of wonder. And to find answers to these questions, the European Space Agency launched a mission called Jupiter Icy Moons Explorer, or Jupiter Icy Moons Explorer, on April 14, 2023 from French Guiana. This mission is truly remarkable, and its scientific objectives will also give a new direction to human civilization. Our science will reach a whole new level, but today, in this video, we will not be discussing this mission. But there is one more thing in this entire mission that I found very interesting. When I was reading about this mission, I came across this timeline. It's been about 5 months since this mission was launched. Currently, it is orbiting the Earth. After about 1 year and 4 months, that is, in August 2024, it will reach the moon. And from there, using gravity assist, it will do a flyby of Earth again in the same month and head towards the planet Venus. Then, after about a year, it will reach Venus on August 31, 2025. From there, it will do a slingshot again. Its speed will increase, and by September 2026, it will do another flyby of Earth. Then it will go into a large elliptical orbit. After about 2.5 years, on January 18, 2029, it will pass close to Earth again, but this time it will leave Earth's orbit and cross Mars's orbit. It will pass through the asteroid belt, and by asteroid 223 Rosa, it will enter Jupiter's world, but by then it will be July 2031, and then it will study the rest of Jupiter's systems. Now, just looking at this timeline feels strange because its science phase is only 3 to 5 years, the cruise phase of this mission. That means the phase where the machinery reaches its destination in ideal conditions. Why is that 8 years? To put it simply, why is it taking the Jupiter Icy Moons Explorer mission 8 years to reach Jupiter, whereas earlier the Voyager mission reached Jupiter in less than 2 years. Besides that, the New Horizons spacecraft didn't even take a year to reach Jupiter. So then, despite having advanced technology, what is it about the Jupiter Icy Moons Explorer mission that it's taking so much time to reach Jupiter? And when Jupiter and Earth are close to each other, the distance between them is about 600 million kilometers. But in these 5 months, Jupiter Icy Moons Explorer has already traveled about 370 million kilometers. Meanwhile, if we look at it in terms of time, our spacecraft is currently following a particular trajectory. So the question arises here, why is it like this? Why can't we go straight to Jupiter? Why are we wasting so much time? The answer depends on factors like the rocket's power, spacecraft weight, and payloads. The amount of fuel and the geometry of the planet, all these things decide how we have to reach a specific planet. Look, orbital mechanics is a field where anything can happen at any time. For example, despite having a lot of fuel, Luna 25 was not successful, but even with less fuel, the Chandrayaan mission became a big success for India. Everything is in motion here, whether it's planets, moons, stars, galaxies, clusters, or even larger structures. When we launch a mission, it's not launched from a still Earth, but from the Earth, which is orbiting the Sun at a speed of 30 kilometers per second. In such a situation, targeting your mission from one moving object to another moving object is a complicated task. When Earth and Jupiter are on opposite sides of each other, the distance between them can reach up to 968 million kilometers. But when these two planets come closer in their orbits, this distance reduces to about 600 million kilometers. But this position and this minimum distance only last for a few moments, and after that, the distance starts increasing again. Another problem is that each planet orbits the Sun at its own different speed. That means engineers will have to calculate the entire trajectory of the mission with complete accuracy. Because in this empty space, we will have to launch our mission in such a direction, where currently the planet is not there, but as soon as the mission reaches the planet's orbit, the planet moving at its own speed will arrive there. Now imagine that you have a powerful rocket. You launched it on the trajectory with the shortest distance, and that too at the right time. Now, how much time will it take you to reach Jupiter? You would want to reach Jupiter as quickly as possible, but still, it will take you at least 1 to 2 years. As we saw earlier, it took Voyager about 2 years and New Horizons about 1 year. Now, the problem with going to Jupiter is that the missions we're taking as examples had to fly by Jupiter. They didn't have to stop there. Now, if you've already made the mistake of going to Jupiter at this speed, then think about how you'll stop at Jupiter without any brakes. So here comes a concept of orbital mechanics, which we call orbital energy. All the satellites orbiting the Earth have negative orbital energy, which means the Earth is pulling them towards itself. When this energy becomes more negative, the satellites start falling towards the Earth, which means the satellites lose energy. So that they don't collide with the Earth, their orbital energy is increased by firing thrusters. But when the orbital energy increases too much, the objects leave the orbit and go far away. So now the point here is that the speed with which you are heading towards Jupiter, you will have to lose that kinetic energy. And to do that, you can fire thrusters in the opposite direction. This will waste a lot of fuel, and to carry that much fuel, you will also have to waste a lot of fuel at the time of launching. And the second thing you can do is reach there with less speed without wasting so much fuel. But for that, you'll have to compromise on time. But in this, we will also get time to maneuver and manage the spacecraft. If the speed is low, then one thing is clear from here, that the weight of the spacecraft plays a crucial role in how much time it will take for the spacecraft to go anywhere. Because more weight not only increases the cost of launching, but also increases the cost of inserting into orbit after reaching the destination. A more powerful rocket is also needed to launch more weight. Adding more fuel to the spacecraft increases its weight, making the launch harder and the mission more complex. While launching from Earth, we have to provide the spacecraft with a specific minimum velocity, which we call escape velocity, so that the object can escape Earth's gravitational pull. If we talk about the JOS mission, it is the heaviest interplanetary mission so far, with a weight of more than 6,000 kg. To launch it, one of the most powerful rockets, the Ariane 5 heavy lift rocket, was used. But even this rocket wasn't powerful enough to send JOS directly towards Jupiter. That's why gravity assist was used here. Now, we know that the closer an object is orbiting to Earth, the lower its orbital energy will be, and the farther an object is, the higher its orbital energy will be. In the same way, all the planets also revolve around the Sun. Mercury is the closest planet to the Sun, so its orbital energy is the lowest among the planets, and Neptune's orbital energy is the highest. And before entering the orbit of any planet, it is necessary to match its orbital energy. When the Epicolombo mission was launched for Mercury, at the time of launch, its orbital energy was equal to Earth's orbital energy. But to enter Mercury's orbit, it had to lose energy so that it could match Mercury's orbital energy. To lose that energy, Epicolombo had to fly by other planets. The vice versa is also true. If we have to go into a bigger orbit, let's say Neptune or Pluto's orbit, obviously their orbital energy is higher. So to reach there, our spacecraft will need that energy and we will have to gain that energy. Or you can say that we have to steal it from planets like Earth, Mars and Jupiter. Now your question might be, in both cases, that is, one when we are losing energy and the other when we need extra energy, in both cases we are doing a flyby of the planets. So how can we gain or lose energy by doing a flyby of planets? The answer to this is relative motion. Yes, we can do this through the relative motion of planets and the spacecraft. With gravity assist, we can speed up, slow down and even change the direction of the spacecraft. If we do a flyby in the direction of the planet's orbit, the spacecraft gets an excellent boost which increases its speed. And if the spacecraft does a flyby from the opposite direction, its speed decreases. Here, according to Newton's third law, the momentum of the system remains conserved. This means that if the spacecraft's speed is increasing, the planet's speed decreases to conserve momentum. But since the planet is a very massive object, these changes become insignificant. You can also understand this whole process like this. If a spacecraft is withdrawing energy from a system, obviously that system is a planet, then the planet's orbital energy is decreasing. If the spacecraft is losing energy, then the planet's energy is increasing. Because according to Newton's third law, the total energy of this system should remain constant. But these changes are so insignificant that we ignore them. So, the JUICE mission was launched from Earth, so just after the launch. The orbital energy that the JUICE spacecraft will have could be a little less or a little more than Earth's orbital energy. JUICE will need extra energy to reach Jupiter because Jupiter's orbit is bigger than Earth's and it's farther away. It will gain energy by performing flybys of Earth, Moon and Venus. And throughout this whole process, it also needs to slow down so that its energy matches with Jupiter. And this crucial thing is what increases the cruise time of this mission so much. After reaching Jupiter, it will do around 35 flybys of Jupiter and its moons. It will deeply study Europa, Ganymede and Callisto, and its final focus will be on Ganymede. Jupiter Icy Moons Explorer will become the first spacecraft to orbit a moon of another planet besides Earth's satellite, that is, the Moon. The most crucial moment of this entire mission will be when the Jupiter Icy Moons Explorer spacecraft slows down to 1 kilometer per second while orbiting Ganymede. And then it will be inserted into Jupiter's orbit. Inserting a spacecraft into orbit around any celestial body is very difficult. The spacecraft has to maneuver at a perfect speed, at a precise angle, at the right moment, and in the correct direction with the correct amount of adjustment. Only then does the spacecraft get established in orbit. If the maneuver is done too fast, too slow, or at the wrong time, the spacecraft either crashes directly into the planet or gets lost forever in this infinite space. Then, even more fuel can't correct the spacecraft's path, which is why the right amount of motion or the right amount of energy matters much more. That's why this mission will be able to reach Jupiter by 2021. I hope this aspect of the mission is clear to you now. Friends, if you want a detailed video on this mission, be sure to write Jupiter in the comment section. The largest planet in our solar system, it can contain 1,300 Earths within itself. You can get an idea of its immense size from the fact that if you place 13 Earths in a straight line, even they would fit within Jupiter. However, it is much smaller than the Sun, which could hold 1,000 Jupiters inside it. But except for the Sun, even if all the other planets are brought together, they still wouldn't be able to match this giant Jupiter. Brihaspati planet is the fifth from the Sun, with Mars ahead of it and Saturn behind it orbiting the Sun. Brihaspati is a gaseous planet, which means it doesn't have a solid and rocky surface like Earth. It's completely made up of gaseous clouds. Most of this planet is made up of gases such as hydrogen and helium. Therefore, scientists estimate that somewhere deep beyond its cloudy layers, there is a place where boiling magma exists. Jupiter also has a liquid core, which drives the planet's extremely mysterious magnetic field. It is because of this planet's mysterious magnetic field that scientists have not been able to fully understand it to this day. So come, let's embark on this journey to Jupiter together and uncover the secrets hidden behind the planet Brihaspati. Brihaspati is the fifth planet in the solar system. It is a gaseous planet, meaning its structure is made up of a combination of gases. Around 4.5 billion years ago, when the solar system was formed, certain conditions caused hydrogen and helium to move away from the sun while dust particles moved closer. As a result, rocky planets with solid surfaces soon formed near the sun. Meanwhile, a little farther from the sun, beyond the asteroid belt, those planets were formed which we know today as gas giants. According to researchers, gas planets like Jupiter and Saturn originated from the same gas cloud that once gave birth to our sun. Well, it was only after a long period of accumulation of these gases that these planets were formed. Space is a subject full of mysteries for humans because till today, whatever we know or have heard about it, there is no scientific evidence available for any of it. Meanwhile, in Europe, a great astronomer and scientist named Galileo Galilei emerged. Galileo was the first scientist who started observing space with the help of mirrors and lenses. With the help of these lenses, Galileo confirmed the existence of the planet Jupiter in space. Whether it was the ancient civilization of Greece or the Vedic culture of India, these ancient civilizations described Jupiter in their own way, but now they are known as Galilean moons or Galilean satellites. That was one era, and this is another. Over the past centuries, there have been many developments in technology. Today, humans have deployed highly advanced space telescopes in space. With these, we have discovered many secrets of Jupiter, whether it's the mysteries of its magnetic fields or the extremely complex structure of this giant planet. Indeed, we have been successful in gathering information related to Jupiter. Until now, scientists believe that Jupiter was also formed from the same hydrogen and helium cloud from which our sun was once created. But recently, a research has emerged that questions this theory. So in the past 5 decades, how did these heavy elements end up on Jupiter when we didn't find those elements on the sun? And it's believed that both of them were formed from the same cloud. To solve this mystery, we need to take a closer look at the team of scientists who worked on National Aeronautics and Space Administration is Galileo spacecraft, who found in their observations that the movement of these heavy elements to Jupiter seems to be drawn from some external source. Eventually, it falls inside and merges with it. Thus, this study is rejected. Recently, a new report has also come out in which scientists have suggested another possibility. According to this new report, Jupiter was actually never born near the sun. Instead, it originated from another cloud, which was about 4 times farther from our sun's orbit. This new report has been prepared from the data collected by the Juno spacecraft. Mystery number 2, the presence of water on Jupiter. Water is the key through which we can understand how Jupiter was born in the past. The asteroids and comets passing near Jupiter increased the presence of heavy elements on Jupiter. Along with this, the presence of hydrogen and helium on Jupiter was also significantly affected. A recent research has compelled us to find out to what extent the presence of water on Jupiter has been affected after such comet and asteroid impacts. This is about the year 1994 when a comet named Shoemaker-Levy 9 was moving towards the sun at a very high speed. In such a situation, it crossed paths with Jupiter and no one realized when this encounter turned into an accident. I mean, this comet, you know. In no time, it collided with Jupiter, but before it could merge into Jupiter's gaseous clouds, before that, Jupiter's intense tidal force destroyed it completely. It broke into many small pieces, and those pieces fell into Jupiter's Jupiter one after another. 20 years after this incident recently, the Herschel Space Observatory performed an observation on Jupiter. So there was a huge reservoir of water and those pieces, they fell onto Jupiter. Earlier, a research team from Juno had traced a significant amount of water in Jupiter's atmosphere. This team had found that 0.25% of Jupiter's total atmospheric molecules are water, that is, H2O molecules, which was a much bigger number than the previous reading. Mystery number 3. The truth about Jupiter's core. Understanding Jupiter's physics is a headache even for big space scientists. The wire keeps getting longer, and somewhere in between, there comes a stage where we see a substance in liquid form. This substance can conduct electricity just like a metal. In 2011, mystery number 3, the truth about Jupiter's core is also a headache for the physics of Jupiter. For now, Juno, which is currently orbiting Jupiter, is focused on its core. For now, Juno's biggest objective is to find out the percentage of heavy metals present in Jupiter's liquid core. When we look at pictures of Jupiter, the striped lines and circles present in them often catch our attention. Actually, these are storms happening on Jupiter. In most pictures, we only get a top view of these storms. In such cases, no one can see beyond these clouds. What secrets does Jupiter's extremely dense atmosphere hold? Data from Juno has revealed that these storms, which appear as bands and circles, actually extend thousands of miles deep. Long-term studies of Jupiter's weather can reveal many secrets, including those of the storm that has been raging for the past 200 years. Whether it's the reason behind the shrinking of the Great Red Spot or the precise demarcation of the compression point of the storms raging on Jupiter, if we want to uncover the mysteries of these planets, we'll have to wait quite a while. In fact, from the 16th century until today, whenever we've looked toward Jupiter, the storms raging on it have always attracted us. What is your opinion about this? Will we ever be able to understand the storms raging on Brihaspati? Is there any other planet or body in our solar system besides Earth whose exploration could help us uncover the mystery of life? Is there an unknown planet where the seed of life is growing, the one we are searching for without knowing? For how many years have the possibilities of life been explored on Europa, the moon of Jupiter, the fifth and largest planet in space? Well, for your information, according to the International Astronomical Union or International Astronomical Union, while our Earth has only one moon, in contrast, Jupiter or Brihaspati has many times more moons. Altogether, this planet has a total of 95 moons, out of which the 4 largest moons are Io, Europa, Ganymede and Callisto. They are known as the Galilean moons, named by the discoverers. It is suspected that there is a possibility of the presence of water on one of these moons, Europa. Friends, Europa is also called Jupiter's icy moon, with a diameter slightly less than our moon, about 3,138 kilometers. It is the 6th largest moon in our solar system. Europa was discovered by Galileo Galilei in January 1610. German astronomer Simon Marius had discovered this moon at the time when Galileo was observing Jupiter's moons. That's why he is often credited as the co-owner of the moons. Now talking about Europa, friends, It is just like an icy world, where for miles and miles you will see nothing but ice and its rocky formations. And the conditions here are so dangerous that in just a few minutes the freezing temperature will turn you into an astronaut popsicle. Speaking of human life, we know very well that Earth has an atmosphere which is a mixture of different kinds of gases. This mixture contains about 21% oxygen, and this is the gas that keeps us humans alive when we inhale it. But if we talk about the atmospheric differences between Earth and Jupiter, it's important for you to know that while Earth has a very thick layer of atmosphere, on the other hand, Jupiter is so far away that its atmosphere is very fragile. So fragile that your life would be at risk within just a few moments. One special thing is that, unlike our moon where we see large craters, you won't find similar craters on Jupiter's moon. That's why scientists believe that there must be something present deep below the surface, which even after meteor impacts, helps this moon recover from them. But if we talk about the data, according to it, there is a good amount of oxygen on Europa. That means the oxygen that humans need to survive is definitely present there. It's possible that life could exist inside the depths of Europa as well. For this information, National Aeronautics and Space Administration scientists constantly keep an eye on this moon and also on the activities happening there. They occasionally add it to their research list. But even then, you won't be able to breathe this oxygen because the pressure here is so high that you can't even take a breath. The reason why Europa is so interesting for scientists and astronauts is the possibility of liquid water existing beneath the sheet of white ice. By looking at some new images, we get more information about the marks and cracks on Europa, which National Aeronautics and Space Administration hopes to use. National Aeronautics and Space Administration believes that, compared to any other body in our solar system outside of Earth, Europa has the highest possibility of microbial life existing. That means even under very high pressure, there could be some bacteria present that have not been discovered yet. If their claim proves true, it will be a new achievement for our science. After all, National Aeronautics and Space Administration has also planned a mission to land on the icy surface of the moon and drill through the ice shell into its oceans. However, this will still take a while. Friends, the deepest point on Earth is said to be about 10 to 11 kilometers deep. Europa's ocean may be up to 100 kilometers deep. If we talk about Europa's subsurface, it is believed that due to Jupiter's gravity, the force of attraction and the tidal energy generated by Europa's elliptical orbit, if we talk about Europa's subsurface, to find out if there is actually something swimming around in the depths of this ocean, according to the images taken by National Aeronautics and Space Administration spacecraft Juno, this planet, which is located far away from Earth, could become a new place for the existence of life. Europa's crustal layer is completely covered by these large frozen icy rocks. But deep below, there is salty water, and researchers even claim that the amount of water present on Europa is much greater than that on our Earth. Scientists say Europa's ice layer is about 20-24 kilometers deep. Beneath this, there could be a deep ocean and possibly many mysterious creatures living in it. In addition, scientists have also discovered natural elements like carbon, nitrogen, oxygen, sulfur, and phosphorus on Europa. This year, National Aeronautics and Space Administration is going to launch a mission to Europa with the help of SpaceX Falcon, which is considered one of its most powerful rockets so far. This mission will be called the Europa Clipper mission. However, before this, National Aeronautics and Space Administration's Voyager 2 spacecraft, Galileo Orbiter, and Hubble Space Telescope are 3 or 4 such missions through which all the information about Europa and related discoveries have been obtained so far. If I explain in detail, friends, Voyager 2 spacecraft took some pictures of this moon for the first time during 1989. This revealed that Europa's surface is covered in lines and cracks. And because of these, scientists estimated that Europa might still be geologically active today. Missions took place from 1983 to 2003, and the Galileo mission also collected significant information. In September 2022, a spacecraft named Juno was just 340 kilometers away from Europa and took close-up pictures of its surface. It shared them with our scientists. In 2023, the Jupiter Icy Moons Explorer mission will study Jupiter and its 3 icy moons, Europa, Ganymede, and Callisto. It will make many flybys near Europa. Europa Clipper is not just a mission to search for life. Its main objective is to confirm whether there are places beneath Europa's surface that could support life. For this, the space module will orbit Jupiter and conduct close flybys near Europa with the intention of collecting data on the Moon's atmosphere, surface, and interior. While the Europa Clipper spacecraft itself won't be able to search for life, it will only set the stage for future missions. This spacecraft will pass very close to Europa, and sending a mission this far will still require a lot of expense and effort. But one thing is certain, after overcoming every difficulty, we will know this for sure: whether there is really a possibility of life existing somewhere other than our Earth. This is the sun, which gives life and energy to our entire solar system. But in the beginning, everything wasn't so calm. When the sun and our solar system were forming, there was a lot of chaos in this entire solar nebula. Terrible storms were erupting from the sun. Because of these, lighter materials like dust and gas were pushed away, while the rocky materials remained near the sun. Amidst this turmoil, all the rocky planets in the inner solar system were formed. Mercury, Venus, Earth, and Mars came into existence, but outside this inner solar system, something very mysterious was happening. Gas and dust particles came together to form 4 giant planets, Jupiter and Saturn. These two were called gas giants, while Uranus and Neptune were called ice giants. From the beginning, scientists have believed that these gas giant planets have a core, meaning their central part is definitely rocky. Because how is it possible that the gas that moved away from the sun got divided exactly into 4 gas giants? There must have been small rocky planets there, which attracted the gas with their gravity. But there was so much gas that those small planets just became the core of these planets. If we talk about Jupiter, scientists believe that above its solid core, there is a metallic environment of hydrogen and helium. Jupiter is so huge in size that as we move towards Jupiter's core, the pressure starts increasing very rapidly. By the time we reach the center, this pressure increases so much that because of it, hydrogen and helium get compressed so much that they start to show metallic properties. Anyway, it's not possible to reach the core of any planet and study it, and that's why the rocky core of gas giants has remained a mystery in planetary science, which probably still exists today. For the scientists who were studying Jupiter, Jupiter's core was nothing less than an illusion. Such a huge planet and the extreme pressure in its core was pushing our understanding of the behavior of matter to its limits. That means beyond that limit, we didn't know how matter behaves under those extreme conditions. The pressure inside Jupiter is millions of times greater than that of our Earth, and the temperature at its core is more than 20,000 degrees Celsius. Now, because these conditions are so extremely intense, we would need equally extreme instruments to simulate them, which can help us understand the science beyond our current limits. For this, nothing could be better than the Center for Matter at Atomic Pressures, or Center for Matter at Atomic Pressures. This instrument at the University of Rochester has the world's most powerful lasers, which can compress materials so much that the interior of Jupiter can be easily simulated there. The Laboratory for Laser Energetics Department at Rochester has the world's finest laser fusion facility. This lab has a 60-beam laser system which can simulate Jupiter's inner core for our samples like hydrogen and helium or any rocky material. By the way, scientists were not always in agreement about Jupiter's core, but how this mystery turned into a crisis is a very interesting story. Actually, the Juno spacecraft is orbiting Jupiter, getting so close that it is taking images where the clouds on Jupiter are clearly visible. Now, by precisely tracking Juno's orbit, we can easily trace Jupiter's gravitational signature, which will help us understand how matter is distributed inside Jupiter. And that's where things start to go wrong. The results we got from the data collected by Juno were completely different from any of our previous models of Jupiter. That means all the predictions from our old models are saying one thing, but Juno, which is currently near Jupiter, is telling us something completely different. And this very confusion revealed that the concept of Jupiter's rocky core in our classical models is not correct. It's not easy to create a new model where Juno's data fits in. The laws of physics decide how the layers inside Jupiter will be organized, how much matter will be in each layer, and what the pressure and temperature will be at each place. All of this is determined. If we make any changes in the model using the equation of state, then it should be according to the equation of state, and we will find all this out from the behavior of matter, how matter behaves inside Jupiter, and this is where the camp laboratory becomes important. With this, we can determine Jupiter's equation of state, so finally, we have reached the root of a mystery. According to Backard Millizer, a member of the camp team, we will have to abandon the idea of Jupiter having a solid core, because Millizer's team presented their findings to everyone by exploring computer models and different configurations of planets. The findings indicate that Jupiter's core is dilute, meaning the core is not completely rocky. In fact, about 63% of it is spread outward in a loose form. The core of a large planet like Jupiter is spread over about 2/3 of its radius, which means it can't be a simple core at all. This is completely different from the compact solid core that older models predict. Millizer's team found that only 1/8 of its core is rocky. What if Millizer and his team's results turn out to be correct? Our classical concepts, old ideas, old models, and our understanding of planets will all take a serious hit. If all our models turn out to be wrong and our understanding of planetary evolution itself is proven incorrect, then we'll have to start understanding everything from scratch, which will be nothing less than a crisis. But for now, these new models still need to be confirmed. And that's the beauty of science, that whatever helps us understand nature better, that's what lasts in the world of science, and all the other concepts are discarded. So, has this mystery been solved, and what are your thoughts on it? What do you think? Does Jupiter have a solid and rocky core, or is this core diluted, or could there be other options as well? Be sure to share your thoughts in the comment section below. And friends, if you like this video, please like it and share it with your friends. For more informative videos like this, make sure to subscribe to the channel and enable the bell notification. Friends, we'll be back soon with another informative video. Until then, stay curious and happy. Hello, if Europa is present,